I want to talk about optimizations that you can make in .NET and whether or not they're worth it. This is going to be very .NET specific because that's like the main framework that I work in. But honestly, some of these principles could probably translate over into other languages and frameworks. Like I would imagine a lot of this stuff could probably be translated into Java and Spring. So one optimization that you can make in .NET is moving to minimal APIs. Now, before you hear that and you say, "Oh, should we switch our all of our controllers, and switch them over to minimal APIs and just do our all of our maps on like the program CS file?" Probably not. If you already have an existing project, there's really not a lot of incentive to switch over and use minimal APIs. I've used minimal APIs, but my primary choice is still going to be the standard controllers and then reflection to map the controllers, just how it is out of the box without minimal APIs. The reason minimal APIs are a little faster is because you don't have the plumbing, as we'll call it, behind the scenes to basically use reflection to map the controllers, right? So if the naming style is home controller, I don't know, weather controller, right? You have to have controller at the end, and in your route it's just going to take the first part of that name. So if it's home controller, or weather controller, the route will be weather. That's just the .NET way. And minimal APIs basically get rid of that, and then you can just specify the route name. But everything's on that middleware pipeline, the startup, right? So all of your routes are mapped, and there's nothing behind the scenes that has to figure out and go and reach out to that file and route it there. So you save a little bit of time, and when I say a little bit of time, depending on your application, you might save maybe a few hundred milliseconds or something in the ballpark of that, which is not a lot, but it's also not a negligible amount. You will see performance gains if you use minimal APIs. However, if you have an existing project, like we said, it's a robust project, it's a big project, you have a lot of controllers, and you have all the routing already squared away, you probably don't have a lot of incentive to switch to minimal APIs. The performance boost is just probably not, probably just doesn't justify spending the amount of effort it would take to migrate all your controller code and put in program CS. And I should say that it's not impossible, like you can do this, but then you just have all that logic contained in one file, and I just don't know if I want that. I just don't know if I want all that stuff in my program CS file. And that just might be my own bias because I'm used to the other way, but I just kind of like the separation. And I know obviously there are patterns you can incorporate to include files in the program and do it that way and still take advantage of minimal APIs. I get it, but it's just like that feels like I'm making the same thing, except I'm now adding a new layer of complexity that somebody coming into the project, if they haven't worked in minimal APIs, has to then go and figure out. So that's kind of my issue with it. Now, if you're making something from scratch, yeah, minimal APIs are a legitimate thing to choose. But minimal APIs don't replace the alternative, right? The standard controller way. Not at all. It's just a different path if you want to take that. There's a little bit of a learning curve, a little bit, because it's a little different syntax, and you have to think through things differently in terms of like how you're in authorization and how you're grouping things and the routing specifically. It's a little bit different, but not that extensive. So you'll hear minimal APIs be thrown out there as an optimization you can make. And that, at its core, is true, but might not be worth your time, potentially. Another optimization is around code performance and really about specific patterns in .NET that you can do. or I guess really in C Sharp specifically. Um, Getting hung up on micro optimizations in code can be a really big time sink, especially if you have already working code that is pretty efficient, and then you go back and try to continuously refactor and try to make the slightest performance gains to gain, 30, 40, 50 milliseconds. Those kind of things are a massive time sink, and sometimes those often produce code that is, one, harder to debug, or two, written in a way where if there are problems, it makes it so that somebody else coming into it is going to have a harder time figuring out what went wrong. This is a common critique of when you start introducing any kind of concurrency in code. So if you do any parallel for eaches and it's accessing like a concurrent dictionary or something like that, if something happens there, it's a lot harder to debug, and you start introducing the possibility of there being some kind of obscure race condition, right? That's just inherent with any kind of concurrent programming. And .NET has some safety features built in. So, like I brought up concurrent dictionaries. There's concurrent collections built into .NET that allow for you to write pretty easy parallel code or parallel loops that access a shared collection. And those concurrent collections already take care of blocking and all the stuff that you need built in to accommodate for potential problems that might exist as a result of you introducing concurrency. Now, if you mess up and you don't use a concurrent collection, it'll probably throw an error pretty quick, and you'll catch that. But there's still the thing that you need to consider of if you introduce concurrency, you just got to make sure you kind of got all your code lined up elsewhere. After that, you got to make sure you have all your safety that you need. But also, sometimes introducing concurrency can actually add time, because in .NET specifically, every time you spin up a new thread and put it on the task scheduler, every time you spin up a new task and it puts it on the .NET's task scheduler, that takes a specific number of time. So if you've executed ever a parallel loop versus just a regular, let's say, for each loop, the parallel loop, given a smaller collection size, is going to take longer, just because there's a associated time that it takes. There's a time associated with spinning up a new task and then the task scheduler coming in and handling it, right? Because whenever you introduce parallel code, especially if it's asynchronous, then you have to take into consideration that every time you make sure that it's non-blocking. But if you look at the .NET's task scheduler, there's a few configurations that you can do to make your code work. But the task scheduler is, I would say, a little bit resource intensive compared to not using it. So collections for smaller sizes are going to take longer than just your traditional, let's say, for each loop. Where you're going to see the performance gain is on massive collection sizes, a million plus collection sizes. So if you're dealing with relatively big data, kind of small, but larger data sets, and you have to do complex operations. Let's say you're looping through, 10 million records, and you have to make you perform one logical operation on it, then you have to make some kind of call out to some service and get some data back and then merge the two sets. Then you might notice some serious improvements if you introduce concurrency. But if you don't, then you're still going to have functional code, but it might, maybe it'll run a couple seconds, not as fast. So there's all these things you have to take in mind. But just kind of arbitrarily introducing concurrency into .NET can be kind of a big time sink. But two, it might actually make it worse when you thought it would make it better. Another area in terms of code performance that you can kind of get stuck in is the pattern that you choose to code in. The kind of the hot topic right now is functional programming. And if you look at a lot of C Sharp's current language features that are being added into the latest versions, a lot of those actually come from F Sharp. So if you've ever used F Sharp, it's .NET's functional, basically alternative to C Sharp. It's been around for a long time. And F Sharp has a lot of features that are being introduced into C Sharp, essentially. So a lot of these functional programming styles are being introduced in C Sharp in the form of like I'm trying to think of like a recent example. I know one is like I think they're introducing union types, which is interesting. Obviously, we've had anonymous functions for a while. We're getting like mapping, map reduce patterns. Link is introducing a ton of this stuff that's been around in more functional languages for a while. We're getting strategies now to avoid creating the intermediary variables when sending data through like a pipeline. So functional programming has advantages because the way it's structured is it lets you set up, in particular, it lets you set up almost these pipelines, right, for your code to send data through methods. So you can do method chaining is what it is. And method chaining allows you to basically provide a function as the result of another function, right? So if you send data through a function, the output will be another function. So you avoid this like intermediary result, like var result equals, get sum of 2, and then you take that result and you say, var next result is equal to, multiply by 3, those kind of things. In functional programming, you could chain those together and basically set the direct result of get sum of 2 and then pass it into what I said, whatever they wanted to say, multiply by 3. And you can chain those together and avoid the intermediary variable. You can read about techniques like this if you look up like deforestation patterns. So that's actually a pretty cool feature that C Sharp is getting by way of Link. You'll see a lot of these features added in Link. But they're really, really good features, but they're a little bit delayed compared to what F Sharp has. So honestly, if you know F Sharp, you can do some seriously powerful programming in F Sharp, especially if you're working with any kind of like broker type patterns. F Sharp has a what is it called? It's called oh my goodness, what is it called? It's I think Mailbox. It's like a mailbox processor, I'm pretty sure. You can look it up, but it's basically this. It's an agent pattern where you have like this concurrent like message handler. It's kind of like a queue, how we would think about it, but it's basically this concurrent mailbox where data can come in and then something acts upon it and then outputs a result. And the reason why it's powerful in that sense is because that C Sharp doesn't technically have, in a sense, a direct out of the box equivalent, at least not that I know of, to mailbox processor. I think they're introducing a lot of that into the languages as of later versions, but that's feature's been around a while in F Sharp. And if you know how to code with F Sharp, you can use F Sharp inside a C Sharp application. So you can create seriously powerful like components, call them from C Sharp, and you can write some really, really powerful code. So if you've never used F Sharp and you have a reason to, maybe give it a shot, because you never know like what you can get out of trying a different language and what features are available. And just the fact that you can use a functional language means you can take advantage of just the inherent safety you get with immutable types and thread safe looping in parallel over collection. Those things are just kind of built into functional languages because the types, the objects are immutable, whereas they're mutable in C#, and so you have to make some accommodations. Well, getting back to this, in terms of just code performance and optimizations that you can do, one specific functional feature that is in C# is called a propagator block. And a propagator block basically allows you to encapsulate methods and chain them together, and it creates a pipeline where you don't call it, you actually send data through it, and then you can receive it back. So basically you have this, you chain a few methods together, you can send data through it, and then at a later time in your code, you can say, hey, get me receive that message and let me get the result. The reason why it works really, really well, and if you've ever used propagator blocks before, the reason why they work, there's a few different ones you can do. You can do, I'm not gonna remember this off the top of my head, but there's action blocks, and I forget what the other one's called. Buffer blocks, I think. One of them allows you to specify an output, and one of them doesn't. The ones that let you specify an output result, which is that action block? I don't know. I'm not gonna remember. But one of them allows you to specify an output block. And basically, you can create this func, like a function, and provide whatever logic you need. But the output of that you can chain to another method. So you can define your methods and then chain them, link them together. You can link to, and then you specify the next method. And you avoid, again, the intermediary variable from all that stuff. And the reason why it's really, really powerful is because you can make really, really complex and powerful pieces of code completely avoiding any kind of result type. And you can create a pipeline where you can send data through. And I've used this in a real setting, and it was very, very fast, and it was faster than than just writing your typical non-functional code, right? You're just maybe more object-oriented sequential type code, we'll call it that. It was faster, but the problem with it is that it's just inherently more complex and harder to read. Functional syntax is, in my opinion, just a little bit harder to sometimes to wrap your head around. The syntax is a little different. But propagator blocks are a really, really powerful tool. But the pattern can be a bit awkward, I feel like, if you wedge it into a super non-functional solution. So there's that kind of trade-off. And again, it can be argued that it's a micro-optimization. But it might not be if you have a ton of data you're throwing at it, because you can make really sophisticated pipelines. And also, the nice thing about it too is it makes it really, really easy to pass a cancellation token through the whole thing. And every method will notify the next method of completion, and it'll pass the same cancellation token through the whole pipeline. And it works really well. I honestly, I need more practice with it. I've only used it a handful of times, but I would love to introduce this pattern into a real world setting, because having a pipeline and changing it from, hey, you give data to something, you get a result, whereas you change it now to you're sending data through, like instead of like a push, like polling, you're pushing data through a pipeline or something. It's a different way of thinking about it, and for at least from when I used it, I saw performance gains. And again, we're leaning again on the micro optimizations in .NET, but it's worth a shot if you've ever tried it or experimenting in .NET. But those are a couple things that you might see maybe brought up in terms of like just core code level micro optimizations that you can make or experiment. Obviously, some other ones you're going to see are, is the always, debate as to whether or not you should use entity framework versus just using you know, on like just using Dapper or something like that. My personal preference is to use Dapper. We can talk about that in another video. That's another optimization thing that you'll see debated on the internet. Trying to think what else. You'll see other optimizations as to whether you not you should use what am I thinking of? I don't know. I'm gonna leave it there. We talked about this enough, but very .NET specific. But hopefully, I'm gonna talk about a different optimization next time. So I'll see you next video.